Okay, in this video, I'm going to go over the interest rates. We're going to do basic interest rate, what derives it, and we have to solve for one of the market risk premium, liquidity premium, or maturity risk premium, default risk, and inflation. I think I mentioned it. So we're going to solve it, make it simple, and then we're going to do pure expectation theory. We're going to do everything in Excel to make it much more simpler. So let's go to the two problems I wanted to work on here. Oh, right here. Oh, there we go. Think I got it. Yeah, screen is shared. Okay. So let's do that first problem here. Kelly Kelly Incorporated 5-year bond. So we're looking at what makes it 7.5%. Now they're giving it to you, which is the nominal rate. And then we're going to compare it to a 5-year treasury bond, 5.3. But in all reality, you're going to ignore the 5.3. So we're going to look at is the Kelly's 5-year bond. Remember, it includes the real risk-free rate of 2.5. So the 7.5. So let's write it this way. I'm going to do it a few ways, or I'm going to do it this way, but I would do these first couple steps first. Is I'm going to select the C column and I'm going to hit the percentage and I want two decimals. The reason I did it because we're going to select the all the percentages there. So let's look at it this way. So this is going to be the nominal interest rate of Kelly. That's the nominal rate of Kelly, and it's given to you at 7.5%. Now that is going to equal, so the 7.5 is going to equal the following. The first thing we got is the real risk-free rate. So that's going to be R starred. Well, the real risk-free rate. And that is at 2.5%. Next is default risk premium. What is in other words, the United States Treasury does not have that 5.3% Treasury bond. But the default risk premium is because this is a company that has default risk, because it could go bankrupt, they have to accommodate that risk and pay a higher interest rate on debt, which means if you want to buy their debt, they're going to pay you, right, their default risk premium of 0.4%. So default risk premium, and that is 0.4. Some reason if I do 0.4, it's not going to work. I'm going to 0.004, and now it does. Next is liquidity premium. Liquidity premium is what's liquidity? How easy is it convert to cash? So if you have an asset that not too many people want to purchase, and it'll take a lot of work to find someone to purchase it, there's a liquidity problem. Therefore, the bond who's issuing it, the company who's issuing the security, has to pay the investor an extra amount because it's not as liquid as other assets. So this one has a liquidity premium of 1.8%. They have to pay you to take on that because not too many people want it. So you can look at it this way. Let's say there's a pizza place that's a small business and no one really trusts it. If they want to issue debt and they want you to buy their debt, they're going to have to pay you a liquidity premium because if you own it, it's not easy to sell. That's important. Next is inflation premium. So inflation premium and bonds go by the same way as a corporate bond or a U.S. Treasury would go the same because depending on what happens with inflation, inflation goes up or down, that's going to be a premium to make up the purchasing power you would lose. So if they're going to pay you back next year, they're going to pay you 1.5% for that inflation because you lose purchasing power as the year goes on. So that's 1.5%. And then next and last is maturity risk premium. What is maturity risk premium? That is how long it is. There is a risk of holding on to a 20-year bond rather than a 1 year. There's a greater chance that Kelly's Incorporated will go out of business in 20 years than it does next year. So it's more risk for you to hold on to a longer debt. They're going to have to accommodate that risk and pay. Well, that question is what we're trying to solve. So we have all those variables, but we're trying to solve the market risk premium. So it's really pretty simple, is that the nominal interest rate will equal 2.5 plus 0.4 plus 1.8 plus 1.5 plus whatever that number is. When you add all those up, it should equal 7.5. So if we want to solve what this is, what I'm going to do is I'm going to hit the 7.5. Think of the equation. I'm writing everything onto the other side. I want market risk premium by itself. So I'm subtracting out every other one. So I'm going to subtract out the real risk-free rate minus the default risk premium minus liquidity premium and minus the inflation premium. Therefore, the remaining balance must be the market risk premium, the remaining part of the equation. If I summed all those up now, if I sum those up, so if I go, I'm going to sum that up, I'm holding down control, and I'm going to add that one in there. That would be 7.5%. So it's pretty simple. Whatever they give you. Now, if you're trying to solve the nominal, all you would have to do was add up those, right? However, if you're trying to solve any of these, what you're going to do is 7.5 and then subtract all the numbers they give you. Therefore, the remaining balance must be what you're looking for. All right, let's do this problem here. So those other problems are very similar to it. Um, you're doing the same thing, so I don't have to go through that again. All right, so we're looking at this problem. This is the pure expectation theory here. So we look at, suppose a 1-year treasury. So I would recommend, let's write this out. I'm going to put a 1-year treasury, and that has an interest rate of 6%. While a 2-year security, 2-year, is 5.2%. Oh, sorry. 2-year is 5.2. Assuming pure expectation theory is correct, and thus the maturity risk premium of treasury bond is 0. So you have to make that assumption for pure expectation theory to work. Because what we're saying here is that there is no maturity risk premium with the 2 or the 3. If there was, it's not going to hold what we're going to do. What is the yield on a 1-year treasury bond expected to be 1 year from now? Suppose that the immediate calculations to 4 decimals, blah, blah, blah. Okay. So we have a 1-year, we have a 2-year of 5.2. And what are we trying to solve? We're trying to solve what is the yield on a 1-year treasury bond expected to be 1 year from now. So look at it this way. This is the 2-year. I'm going to separate that. What we want to know, the forward rate for 1 year, the forward rate from 1 year. So this is year 1. This is year 2, or a year from now. This is for 2 years. Or you could look at it this way. Let's write it out this way. We have 0, 1, 2. Oh, hold on. I'm going to, I forgot, put that percentages. So we'll look at it as years, 1, 2. So we could look at the 2-year treasury. That means it starts today. It goes for 2 years. Or we could just highlight this. It's going from 0 there. So that's the 2-year, and I'm going to color coordinate that. That is at 5.2%. So in other words, you get 5.2% in the first year. Actually, let me just move it there. We get, make it a little easier. Normally I write it, but I couldn't find my pen. That's why I'm doing it a little different here. So that's 5.2 and 5.2. It's a 2-year treasury. You get that per year. And all right. And then what we were given was a 1-year treasury for 6%. And what we're trying to solve is so if you can get a 2-year treasury, if you get a 2-year treasury for 5.2% each year, and we know what the 1-year is at 6%, that means we could figure out, if pure expectation theory holds, what the next interest rate would be. So this is how we would write it. We would write it like this. I would say 1 plus the 2, so 1 plus, well, I should say equals. I'm trying to think how to do it, still show it. 1 plus that interest rate, and I'm gonna go to the power of 2. You get it for 2 years. That would equal 1 plus 6%. I'll just write it out this way so we can see it. Times 1 plus, and I'm going to put an F there for the forward rate. If I drag that down, let's put it this way. So that's 1 plus, and this is the 2-year treasury, 5.2%, 5.2%. Close it up, but that's to the power. Remember, it happens for 2 years. So it's very simple. All we're saying is if we know what the 2-year you get for, that would be equal for each individual year, right? We get 1 plus 5.2. That would be equal to the 2 power. And that's very important because a lot of people forget to put it there. We're getting the 2-year for 2 years. The 2-year treasury we're getting for 2 years, the 5.2%. But that would be equal to if we got a 1-year times 1.06 times 1 plus some interest rate would be equal. So how do we do that math? So that 2-year treasury would be equal to individual year treasuries. So what we would say, I'm going to equals. It doesn't let me do it. I'll have to type it up again. So I'm going to say 1 plus the 5.2 to the power of 2. And what I'm going to do is I'm going to get rid of that on that side, the 1 plus 6%. So I'm going to divide it, right? Because I want that interest rate by itself. I'm going to divide it by 1 plus that 6%. And it's to the 1 power because it only happens for 1 year. So now it's 104.41. And now I'm going to say equals. And then now we have 1 plus F. I want to get the interest rate by itself. I'm going to subtract out 1. 4.41%. So 4.41%. Would that be interest rate? So all it says is if you know what the 2-year treasury is, that means, and then if you know the first year is, that means it is equal. They have the same interest for 2 years. 5.02, I'm sorry, 5.20 times 5.20 is equal to the 6% times the 4.41. So let's see if that holds. I'm over here. That's going to be the 1 plus, so remember, always remember the 1 plus, the 5.2, and I'm going to multiply. It's the same as squared. 1 plus the 5.2, right? That's going to give us a total interest of, remember, it's compound interest, so it's 110.67, and that would be for 2 years interest that you got total. And if you want to, then we have to subtract out 1 to get the actual interest rate. So we're getting a total of 10.67% for that 2-year treasury for 2 years. And that would be equal to, if we had the 1 plus the 6% times the 1 plus the 1 we just calculated, I'll subtract out 1, 6.7% or 10.67%. So it's the same thing, and that's all we're trying to solve is that interest rate. Let me do another problem to make sure we understand it. What if we have, let's look at 1, 2, 3. Let's do 3 years. Oh, made the same mistake here. So let's go 1, 2, 3. Let's say we know what the first year is there's a 1 year treasury. It only goes for 1 year for 3%. And then a year from now for 1 year, it goes for 5%. And then we know 2 years from now that it will go for 7.25%. So if we know the individual years, can we find out what is the 3 year treasury? What would that equal? Well, all we would do is 1.03 times 1.05 times 1.0725. That would equal the 3 year treasury. Now, if we had a problem like this, we have to make sure, so let's do the math real quick, is that the 3 year treasury looks like this: 1 plus the interest rate. This is the 3 year treasury, but you have to do it to the power of 3 because it happens for 3 years. That would be equal to 1 plus that interest rate times 1 plus the interest rate in that second year times 1 plus the interest rate in the third year, right? That's what it's saying. So this is pretty easy because we have these, that's those years. So all we would have to do is multiply those. So let's find that out. I'm going to go equals. So I'm going to go 1 plus the 3%, multiply it times 1 plus the 5% times 1 plus the 7.25%. So that's the total interest you get. And then, of course, I want to subtract out 1, or it's compound interest. So if you add it up, I mean, what is that? That's 5, that's 12.25, 15.25, but you really get 15.99 because it's compounding. The 1 plus the interest rate times 1 plus the interest rate is compound interest. However, remember, that's the product of those three multiplied times each other, 1 plus those interest rates. That means the interest rate of 1 plus the 3 year security to the power of 3 would be equal to that. So we're not done yet. That's not the 3 year security price. That's what the 3 year security, if you multiplied it 1 plus the interest rate 3 times. Remember that it's to the power of 3. How do you get rid of that? Well, I would have to multiply that, the exponent there, multiply 1 divided by n for 3 years. So n represents how many years. So I would multiply it times 1 divided by 3, which would eliminate that, and all you're left was the interest rate. However, I would have to multiply both sides. So what I'm going to do here, I know I took out that -1. I don't want that out right now, because what I would have to do is say equal to get rid of that 3 on both sides, I'm going to multiply it times 1 divided by 3. So I'm going to the power of, on this side, you have to bracket it, 1 divided by 3. That is the interest per month. Subtract out the 1. I'm going to put it as a percentage. So what we're getting on the 3 year security, is 5.07% per year. That's the average of the 15.99. Last thing I'm going to show you, just remember, is if I want to compound into the future, I could do, I'm going to multiply those, right? That's going to give me the total interest for the 2 years, 10.25. And if I want to reverse it, you do 1 divided by n, 2 years. That's all I did up there, same concept, to the power of 1 divided by 2. It was for 2 years. See, then it goes back to it. And if I subtract out, I always forget, if it doesn't look right, you have to subtract out the 1. See, it's 5%. Just want to show that. So 5% compounded is 10.25. Let's subtract out the 1. Oh, hold on. Just want to make sure it looks good for you because I took that out. I had to add back that 1, 10.25, and then I'm going to do to the power of, and then bracket it, 1 divided by, it's only for 2 years. I just want to show that. and then subtract 1. We add the 1 for compounding. So if you take 1.05 times 1.05, that's 10.25. Then if I want to reverse it, I do 1 plus the 10.25 to the power of 1 divided by n, and that's going to reverse it. So remember, to compound into the future, we do to the power of 2 or to the power of 3. To reverse that, that's total interest for 2 or 3 years. To reverse that, I have to do 1 divided by how many years that is, and that's going to find the average compound interest rate per year. And that's what we're finding here. If we know the interest rate for the first year, the second year, and the third year, all we want to do is multiply all 3 of those together and then get that 1 plus that interest rate, or it's already in that 1 because we have 1 plus interest rate times. All we do is reverse it. We do it to the power of 1 divided by n, and then that's going to give us the average interest rate per year. In other words, the average interest rate per year is 5.07. So just to put it in there to drive this home, some people have problems with it. It might sound like I'm repeating myself, but so if you got 3%, 5%, and 7.25, that's equal to, again, 5.07, 5.07, 5.07. Any questions, let me know. Hopefully that helps out and makes more sense.